Nice to see everyone here. My name is Rebecca Ivanoff, and I'm the Seed Program Manager at the Ecological Farmers Association of Ontario and the Ontario Coordinator for the Bauta Family Initiative on Canadian Seed Security. My colleague Steph Hughes, who you can see in the participant list, is the Atlantic Canada Coordinator for the Bauta Initiative, and she'll be acting as our technical host today, for which I'm very grateful. I'd like to take a moment to acknowledge the importance of the lands, which we all call home, the land that we live on and work with and plant our seeds into. It's an important opportunity for us to consider our relationship with the land, but also how our relationship with the land was able to come about. From coast to coast to coast, we acknowledge the ancestral and unceded territory of all Indigenous people that call this land home. We recognize the long-standing relationship between the land and Indigenous people, which precedes the establishment of Canada. I'm personally calling in from Guelph, though this place has many names that are not on colonial maps. This place is home to people who can trace their lineage back thousands of years. I'm on the traditional lands of the Chinootan, the Anishinaabeg, and the Haudenosaunee people, and on the treaty lands of the Mississaugas of the Credit. I have commitments to the land, the air, the fire, the water, the seeds, and to our Indigenous peoples in these lands. What are your relationships? And what do they look like to the land and the original peoples where you are? I also wanted to take a moment to acknowledge that today we're going to talk about regulated formal seed systems. And these systems are a product of a settler colonial way of thinking. This is reflected in the events such as this one, where Bauta staff have worked really hard to bring a diversity of voices to the table, but the folks who are well-versed in how to navigate this formal system tend to be of settler colonial ancestry. Going forward, I would challenge each of us to reflect on this legacy, which is intertwined with genocide, land theft, and enslavement. What actions, no matter how small as a seed, can each of us take to bring a more equitable and justice-oriented perspective to our interactions with seeds and seed regulations? Our purpose today is to provide tools and tips and strategies for commercial, farm-based, and aspiring seed growers to increase the quality of the seeds that they're sharing and selling or aspiring to share and sell, and also to increase the understanding around the importance of these germination testing as one of a suite of things that can help assure seed quality in a local or regional seed system. To speak to these topics, we have an amazing lineup of presenters. First, we'll have Axel Diederichsen and Debbie Nordstrom from Plant Gene Resources Canada, followed by Aaron Lyons from Hawthorn Farm Organic Seeds, and finally Chris Thoreau from the BC Eco Seed Co-op. Each of these presenters will introduce themselves briefly, and we'll hear about where they're situated as they go through their presentations. So, without further ado, I'm going to bring up Axel's presentation.
Thank you very much, Rebecca, for inviting us from Plant Gene Resources of Canada to speak to you. You gave a very interesting introduction. It was the first time that I was introduced as a person of colonialistic background. I will tell you what my background is. I was born and raised in northern Germany in a small village. We have a local language that is about to disappear. Ik kon ook wat op Plattdeutsch zeggen. Moin moin, dat is onze sprook. Is ook dobi te verschwinden. It's a language that disappears. I came to Canada in 1998 to work as curator and research scientist for Plant Gene Resources of Canada. And I want to start with another saying since giving this introduction, that is from Johann Wolfgang von Goethe, a German poet and philosopher and botanist. He said, wer nicht von 3000 Jahren sich weiß Rechenschaft zu geben, bleibt im Dunkeln unerfahren, mag von Tag zu Tage leben. The one who cannot account for 3000 years may as well stay in the dark and live from one day to the next day. We live here on Treaty 6 country, and it's the Cree that have here a long history. It's very interesting to see. There's a medicine wheel here close to Saskatoon, and we have visited that several times. Now I start here talking about the Canadian Gene Bank, and the next slide, please. This is an ex situ collection. Ex situ means it's institutionalized preservation of biodiversity, man-made biodiversity, cultivated plants, crop plants, and their wild relatives. 3 locations work together to do that. The Department of Agriculture and Agri-Food Canada took that on. We have Saskatoon, Saskatchewan, there we have seed germplasm, we have Harrow, Ontario, there we have fruit germplasm. Fredericton, New Brunswick has potato germplasm. These 3 locations together form the Canadian National Plant Genetic Resources System. Next slide, please. Here you see our germplasm holdings, very diverse. As you see, it's more than 120,000 accessions. These are bags with seed in them. That includes crops and crop wild relatives. About 80% are the cereals. They are very important for Canada. We also have some that trace also back to the First Nations. You know that they cultivated a few plants, including in Canada also. Corn, beans, and squash are the classics of the 3 sister crops. They cultivated a few more. Many species are semi-domesticated. The Fruit Gene Bank looks after them. And I can tell you that we contributed also some of this germplasm was only preserved in these ex situ collections. We contributed that to projects of First Nation people to work on those, some of the corn cultivars, for example, Gaspé Flint. Next slide, please. Our task, germplasm storage. It's viable germplasm. We have cold storage. That is what also the topic is here. Therefore, seed viability testing is a key activity, and Debbie Nordstrom is in charge of that in our group. Regeneration and characterization, very important. We take the things to the field, grow them out, describe them. We follow guidelines that are followed by international gene banks. And the images here illustrate a few of those activities. Next slide, please. Acquisition is important. About 1,000 accessions are added every year to our collection. And then the regeneration has to happen usually quickly. We get small seed amounts, or we have to regenerate because we have little seeds in our existing collection, or the viability is down. We combine that always with characterization, about 3,000 every year in the field. We have a database that is accessible on the internet. Here are the links in English and in French. And there you'll find, you can search germplasm and also find some information about the germplasm. Next slide, please. We ship germplasm free of charge. We have served 62 countries, more than 62 countries over the last 20 years. We have shipped nearly 150,000 accessions between 2002 and 2022. And you see the trend, it's going up, the amount of shipments per year. We ship small amounts of germplasm free of charge, and it's task of the client then to increase the seeds if they need large seed amounts. Because we have a huge number here, we can only distribute small amounts. Next slide, please. This relates now to the topic, and therefore I show this slide. You can see this is what Debbie Nordstrom is involved with. Her predecessor worked on this. As I said, we have seed storage vaults. We store the seeds for long periods of time. That avoids that we have to increase them steadily. Otherwise, we would have to plant the whole collection every 4 years. Now we have two storage walls. One that is what is marked here in green is at +4 degrees Celsius. And we have another one at -20 degrees. And here I compared the storage after 8 years between 2006 and 2014. That was a starting point. The red column here, for example, in the flax cultivar Normandy, this is stored under +4 conditions where we have dry air, the green column, and this is the same seed lot stored under ambient conditions. And you see after 8 years, a considerable drop in viability from 80% to 30%. So we would have to do the increase right away if we didn't have the cold storage. And here you see for flax, sunflower, interesting. Look at this one here. This line had 40% viability, but after storage, it went up to over 70%. You can see things like that. There was some dormancy. So the germination, this is how we measure it, increased over time. That is the exception though, but it can happen. In general, you see the blue column is always the lowest. So viability really goes down over time. In peas, considerably. In lentils, okay. Barley depended a little bit on the cultivar. The rule of thumb is if you have very good seed quality to start with, then the seeds will also store well. With that, I stop my part and hand over to Debbie, who really does all this work for us. Thank you.
Thank you so much, Axel. It's so interesting to see how dormancy can break and things can improve. Let me share Debbie's presentation now. Can you see that, Debbie?
I can, yeah, thank you. And thanks, Axel. He gave a great introduction. So I will just get right into it. So yeah, my name is Debbie Nordstrom. I'm the technician at the Planting Resources of Canada. Next slide, please. So what I thought I would do, I'll just give an overview of what I do at the Gene Bank, and sort of along the way, I'll intersperse that with some tips on germination. Next slide, please. So one of my duties at the Gene Bank is to test our collection to see if it's viable. As Axel mentioned, there's a documentation on Gene Bank standards, and in an ideal world, I would be testing our entire collection every 5 to 10 years and test all of the new accessions that are coming into the Gene Bank. And this would mean, if you saw those numbers, I would be testing 12 to 24,000 accessions per year. And I don't do that many. So I have to be selective and decide which accessions that I should test. So next slide, please. So one of the things that I rely on is the information and experience of the technicians who are growing our material in the field. So if they know that it's been a difficult growing year and the plants are struggling, then they will ask that I test specifically certain seeds that they've grown. So, but if we have good growing conditions and healthy looking plants with healthy looking seed, then we only test a portion of the plants that were grown in the field, just to have a baseline of viability. And the others, we assume they're the same and above 85% viable. Another thing that I look for is yield. So if there's low yield in a crop, then it may be that the plants were struggling. In that case, and so the seeds may also have suffered. So I also test those ones. So it's also important to note that the technicians, they remove a lot of the seed that may not be viable. One of the ways they do this is by using a blower to remove the lighter seed, or in the case of tomatoes, they'll do something like a float test, but I'll talk a little bit about that later. So that's sort of the field portion of viability testing. But as Axel mentioned, we also have seeds in storage, and we have to test to see if they're alive. So how do I know what to test there? So next slide, please. One of the things I look at is the age of the seed. So some of our collection is old, and so we have to test those accessions. In our long-term storage, it's minus 18 degrees Celsius and very dry. Some of those seeds can be stored for a really long time and still be good. So Kew Gardens actually has a really great website. It's free. And you can see how the viability of a seed changes over time, given its initial viability and the conditions that it was stored at. And I can actually make that link available, anybody who would like it. Ideally, we want our gene bank collection to be above 85%. So that's a brief overview of what I test. Now I can get into exactly how I test. Sometimes I get the question, my seed isn't germinating. How can I get it to germinate? Firstly, if a seed is dead, then it's dead. And there isn't anything that anyone can do to bring it back to life. So, and now a seed can be dormant, but that's a different story. And I'll talk a little bit about dormancy later. But if a seed is dead, it's dead. So the best thing that you can do to get a seed to germinate is to give it the best conditions possible to germinate. So next slide, please. For a seed to germinate, it needs oxygen, water, and certain temperatures. And it also needs, some of them need light too. So when we do our germination tests, we look to the Association of Official Seed Analysts, the AOSA hands-on manual. Yeah. And yeah, there's a little picture of it there. Next slide. So this manual has the ideal germination conditions for a variety of seeds. It tells me what substrate that I should use. Next slide. And next one. There we go, good. So it tells me if I need to reuse a roll towel or if I need to have the seeds on top of a blotter. It tells me if I need to use sand, and then also tells me the temperatures that are needed for germination. It also tells me when I should be looking at the test to do germination counts, and it also tells me what to do if the seed is fresh or dormant. Next slide. So of course that manual is over $200, but there's also a really great online resource to see what the ideal conditions are for seed germination. And if you just Google Kew Gardens Seed Information Database, it brings up a really great website that can give great germination conditions as well. So next slide. So ideally, a viability test would consist of 4 replications of 100 seeds. But for us, that would take up too many seeds. So we modify the test and we do actually 2 replications of 25 seeds. And that gives us just a general idea of the viability of the seeds. In our lab, we label the accession identifier on some germination paper. The paper that we use is specifically designed for germination tests. It stays moist and the roots don't grow through it. We mark the paper with a China marker. Sharpie markers can be toxic to some seeds, so we don't use those for labeling the towels. Next slide, please. Of course, the area that we're working on and all of the tools that we use are disinfected to ensure that we have a clean surface. We'll use a vacuum head or a drop tray to ensure that the seeds are separated. The seeds should be at least 3 times the width away from each other. If the seeds are touching and one seed's moldy, then it will transfer mold to any seed that is touching it. Next slide, please. So we take that test, we fold one edge of the roll towel, and then we roll it up and we place it into a plastic bag. And we ensure that we don't overcrowd the rolls so the seeds are not being squished and we still have, the seeds can still get oxygen. Next slide, please. Then we take that germination test and we put it into a germination cabinet. The cabinet's programmed to the required temperatures that I'd mentioned earlier. Next slide, please. We check the test and we do our counts on the days that are set out by the AOSA. We count the number of normal, the number of abnormal, and the number of dead seeds, and we discard any dead or moldy seeds. Now, a seed can germinate, but it's not necessarily going to reach its full potential of a healthy plant. So to identify these seeds, we check for any abnormalities that might indicate the seedling wouldn't be able to grow into a healthy plant. And this criteria is set out by ISTA, the International Seed Testing Association Handbook on Seedling Evaluation. So we'll look for things like if the primary root is stunted, if it splits, or if it's decayed, or the cotyledons are more than 50% discolored. All of the abnormal seedlings are defined in that ISTA manual. Next slide, please. So all of this information is recorded in our germination database. We'll record the temperatures we tested at, what days we counted on, and what the results were. And the percent normal viability is just the number of normal seedlings divided by the total number of seeds used, multiplied by 100. And we just take an average of the first replication and the second replication. Next slide, please. So we record that information also on the outside of the seed storage envelope. Next slide, please. So one of the reasons that a seed might not germinate is due to dormancy. I mentioned that earlier. Dormancy is important, of course, for seeds because it lets the seeds overcome unfavorable conditions and then germinate when the conditions are more favorable. For example, in our country, a seed that germinates in the fall will not reach its full potential of flowering because it will be killed by frost. Dormancy is very complicated, and there's different types of dormancy, and it's categorized in different ways. I deal with crop species, so I don't have to deal with a lot of dormancy, but the seeds of many wild plant species they do exhibit some degree of dormancy. One type of dormancy that I deal with is in tomatoes. Tomatoes have a gelatinous coating on the seeds that can inhibit germination. So after harvesting, we remove the coating by fermenting. And this also helps with seed separation. We just scoop the seeds and the pulp from the ripest tomatoes in a cup. And then after the seeds have sat in a cup for 3 days, we scoop up the mass on the top. And then we fill the cup with some distilled water. And we swirl the seeds around. And then we let the seeds settle a bit. And then we pour out the water on the top. The mature seeds will sink to the bottom. And if a seed is light enough to float, it probably has not fully formed. It's not quite mature, and it's probably not viable, so we don't save these seeds. We repeat that a few times until there isn't much debris left. And then we pour the seeds into a sieve and rinse them with tap water. And we just tap the seeds onto a tray out of direct sunlight, and then we label the tray. So this method is very effective, but if you do plan on doing this method, it is smelly and it will probably attract fruit flies. So you probably want to plan for that. Beets also have a substance that inhibits germination on their seed coat. And the best way to remove it is through soaking. So there's two methods. One method is from the Canadian Food Inspection Agency and CFIA, and you just put 100 seeds in a cup of water, and you change the water every 15 minutes, and then for the first hour, and then every 30 minutes for the remaining 3 hours. And there's another method, you can also soak them for 16 hours at 25 degrees. And after these methods have been completed, then we just continue the germination test as normal. Some seeds like lentils have a hard seed coat, and that can restrict water uptake. So for these seeds, it's necessary to remove part of the seed coat. And the best way to do this is, I find, with sandpaper. But you have to be sure that you just remove the seed coat and not any of the underlying structures. And when I'm doing a germination test, I won't scarify all of the seeds. I will just scarify the ones that haven't taken up water on the first count. Another type of dormancy is embryo dormancy. One of the ways to overcome embryo dormancy is by pre-chilling. So here the seeds are moistened and put in a 5-degree chamber for a number of days. Then the germination is continued at the recommended temperatures. Another way to overcome dormancy is with potassium nitrate. So we make a solution of dissolving 2 grams of potassium nitrate in 1 liter of water. We use this to moisten the germination paper at the beginning of the test, and then we just continue germination as normal. Next slide, please. I just want to briefly touch on sterilization. So some of our seeds are prone to mold, so we do sterilize them, but for the most part, our seeds are not sterilized for testing. So we do sterilize our soybean seeds. We put the seeds just in a flask. We rinse them with water. We add soapy water. We rinse them again for a minute. We add a solution of bleach for 1 minute. We drain that, and then we rinse them with water again for 1 minute. And then we continue the germination test as normal. So this is the end of my presentation. Thank you very much for listening.
Thank you so much, Debbie. This is exactly what I was hoping to hear. It's so interesting to learn about the process within the institution and all of the really interesting documentation and rules that you are sort of referring back to. And I did not know about the beet dormancy, and I wish I had when I had grown beets. So I am very pleased to hear about that. Thank you again so much. So I'll pass this over to Chris Thoreau, who some of you may know from the CANOVI, the Canadian Organic Vegetable Improvement Program. But he is also has many hats, and one of them is working with the BC Eco Seed Co-op. And he has agreed to talk to us about how they use some of the seed regulations in their germination testing. So thank you very much, Chris. I'll pass it over to you.
Yeah, and I'll refer a little bit to what we do, but I mean, Erin will probably cover that, and some of that's been covered already. So I'll be sort of looking at the regulations in Canada, a little bit of procedures, and these can be used in different ways for different operations. So I'll refer to us a little bit, but yeah, we're going to dive deep into regulations here in the short period of time we have. Okay, so good. Okay. So what I'm going to cover here, I'll just introduce everyone to the Seeds Act and seeds regulations here in Canada. We'll look at how vegetables, roots, herbs, and flowers fit into the Act, as well as their labeling. Then we'll talk about germination testing methods and frequency, and just touch a little bit on purity analysis, which is not germination per se, but is an important quality assurance measure. Okay, so seed regulations in Canada. The sale of seed in Canada is regulated by the Seeds Act and seeds regulations. And the Seeds Act started out as the Seed Control Act in 1905. And a big part of that was the grades tables, which really laid out required germination rates, as well as tolerance for weed seeds. And you can see during what was actually still very much a colonial period, the Seed Control Act was really looking at controlling weeds being introduced to the prairies, and there were fines or prison terms that applied if you did that. So the key there was making sure that the seed that people were offering was pure seed and was not contaminated with weed seeds, especially noxious weeds. So in 1923, the Seed Control Act became the Seeds Act. And this was actually really driven at the time by American seed sellers making claims on US wheat yields that just weren't true. They were claiming yields of around 100 bushels per acre, which would be extraordinary yields even in today's terms. And so what this did was more than just provide standards, required varieties to be registered in order to be sold in Canada. So the Seeds Act basically states now that you cannot sell, import, or export seed from Canada unless the seed conforms to a prescribed standard and is labeled properly. So when we talk about a prescribed standard, it is what is laid out in the Seeds Act and the seeds regulations. Now, when we look at small-scale seed growers, I'm skipping ahead. So looking at why we have these regulations, I know regulations around seed for small-scale growers can be controversial, but seed quality control is a big piece. It keeps low-quality seed theoretically off the market. It's a consumer protection mechanism. So, farmers, gardeners all have faith that the seed they buy is going to grow and it is what it's supposed to be. It helps with pest and disease control, and it's important for international trade. The quality of our standards will ensure that other countries will have faith in buying and using seeds that are produced in Canada. So in Canada, we sell a lot of grains, pulses, and a lot of us on the small scale are working with a lot of vegetable, herb, flower, and root crops. And these are actually exempt from the marketing and selling conditions of other seeds. But there are conditions, so they can be sold without meeting minimum standards for germination as long as they are labeled. So this is important to understand, but also it'll be important to understand why we still want to meet minimum germination requirements, which I will talk about briefly. So we still need to germ test these crops to sell them, and they need to be labeled accordingly. So, in short, you need to have the name and address of the seller, the species and the variety. And it's important that you have the year in which the seed was tested for germination and the percentage of germination of seed. So if it's not meeting a standard, the consumer knows that. And there are cases where you might sell a seed that is below an expected standard in order to make that seed available. The transparency to consumers is very important there. So when we look at seed that does not need to be graded, which means going through like the foundation system or the pedigreed system here in Canada, the testing doesn't need to be done in a lab, but it does need to be done according to a recognized standard method. And Debbie talked earlier about the AOSA standards, and the CFIA also has the Canadian Methods and Procedures for Testing Seed, or the M&P. And so even though these aren't part of the regulations, in order to adhere to the regulations, you do need to make sure you're following a recognized standard. And I'll talk about some of the aspects of that to consider. So germination testing in many ways starts with sampling. And when you're taking seed from a seed lot to sample, you need to make sure it is a representative sample. You cannot process or condition the seed so you're getting all the big seed out and the best looking seed to test that. Because that doesn't represent the whole seed lot. So in many cases, growers might grade their seed and have sort of their best seed, secondary, and sort of different grades of seed, and they can test those separately to see how that seed is holding up over time. That's something I do with my seed, and I know others do it as well. So that sampling is important to get a representative sample. Now, methods, Debbie also talked about this. You do need to follow a recognized method. So as an example in the M&P, for each of the crops here, it talks about the substrata you should use. So is it going to be on top of paper or rolled in paper? Sometimes it can be in sand. There's a bunch of different methods. And many, as you can see, like the sunflower here, can be done with different methods under different temperature conditions. The temperature ranges are quite broad. And then there's our counts, as Debbie also talked about. So when you do your first count and when you do your final count, if you look at the bottom, you can see lettuce just does one final count and no early count. And then, some crops need to be pre-chilled. Some of them need light to germinate. And sometimes there's other treatments that are used to make sure stuff germinates properly, including scarification and other chemical applications for the process. So here's some testing that I'm doing just currently. Actually, I'm just testing the storage ability. This is the same crop, but stored in 3 different conditions. So I'm just doing a quick test here to see if there's any difference in how things are germinating. I know Debbie's shaking her head about my seed spacing here, but yeah, this is just sort of a quick unofficial test. And you will notice at the bottom that each of the tests is well labeled with a lot number, so we're very clear on what the seed is to make sure we have accurate record keeping. So this is the other method here, one of the other methods, the roll method. We tend to do everything at the co-op on top of paper as much as possible. It's the method that just seems to work best for us, though this method here is actually really, really good for making good use of space. So this is a list of some vegetable crops people might be growing seed for, and you can see these ones just have a minimum germination. So there's no higher standard for these seed in Canada that it could be graded to. So at the co-op, we use the minimum standard set by the CFIA to determine whether or not we will carry a seed. So, celery you can see can germinate as low as 55%, whereas you see carrot there around 60%. So for us, everything needs to meet this standard in order for us to sell it. Otherwise, we won't carry it. We have made some exceptions where something was close or something was more rare, and then we would just very clearly state in the description that it is germinating below that prescribed standard. We also know from experience that many seeds will germinate better, like in the field or in a soil medium, much better than they will do on the paper. But we want to be very transparent about what our results were. And then record keeping is very important as well. Debbie shared some of their system. We have a pretty robust system as well, so we can track when stuff is being tested, who tested it, what the counts were, whether it passed the test or not, things like that. And then we actually there's a section on here that's not showing, which draws from the CFIA guidelines, so we can see as we're preparing each test, what are the guidelines we are supposed to be following. Now, the Seeds Act and regulations do not lay out how often seeds should be tested. So theoretically, I can put on my package, it was tested in 2017, germinated at 90%, and I can leave that on there forever. Now, of course, the seed has probably changed germination rate since 2017. And I mean, that's not going to be great for consumer confidence. So it's important that we're testing our seed regularly, and the CFIA recommends every 6 months. So we know that the seed we're selling is being maintained at that standard. And different seeds do degrade at different rates for sure. Now, a complementary aspect to germination, which is covered in the methods and procedures, is seed purity. So a seed is a very specific definition, a structure with at least one ripened ovule with or without accessory parts. So if you think about some of the more complex seeds, there's other components to it, but the seed has to be able to germinate in order to be counted as a seed. And so when we're doing testing, if there's a lot of debris in there, it can really disrupt the process. So part of this is making sure seed is well cleaned and conditioned before it goes into testing. And we can look at things like other crop seeds, weed seeds, and inert matter in terms of the quality of that seed lot. So these things not only affect our germination test, because that extra debris can be something that can be prone to mold in a test, but it's also something that if somebody, a customer or a purchaser, is using a seeder, for example, well, these things can get into your seeding plates. And so instead of sowing the seed you want, you're sowing a weed seed, or you're sowing a stem, or you're sowing something else. So that purity test is important to make sure that the seed we're selling is very clean. Generally, I mean, at the co-op, we will either reject seeds that aren't clean, or we have access to seed cleaning facility, so we can get seed to that point as well. So here is a look at one of the grade tables in a little more detail. So the one I showed you earlier is for seeds that don't really have a grade name or qualify for a grade name in Canada, probably because they're just not economically important here. And you can see what this lays out more than just the minimum percentage of germination, but the tolerance for weed seeds in there. So for a lot of small scale growers, if you're harvesting by hand, it's easier to keep weed seeds out of there. But when you're dealing with, acres or dozens or thousands of acres, it's easier for plants to get in there that could end up introducing weeds into your system. So the grading system is really about tolerance to what you can have in there. And you can see for Canada #2 seed, For vegetables here, I mean, you can have a lot of weed seeds in there per 100 grams versus foundation seed. So this gives you a standard to do that. Again, if you want your seed to meet a grade standard, you do need to have it tested in a lab according to the regulations. But if you're not trying to name something as a grade, you can do these testing to the standard, and that way you know you're selling seed that's equivalent to the standard, even if it isn't graded. So just a few things to cover in terms of overview here. I mean, the regulations, the Seeds Act and the M&P, they're big documents. There's a lot of information there, and they can be very intimidating to go through. So what we covered here is a general overview, but there's other things to consider as you get more into it. There's a lot of information to cover, to go through, even for non-graded seeds. So it's good to be very familiar with both the Seeds Act and seeds regulations. Now, despite the exemption for these seeds, it is still important to do the regular testing and labeling and record keeping. And this is important to maintain consumer confidence in seeds. Now, as small scale growers, I think it's particularly important because when you're small scale, you kind of fly under the radar. You know, the CFIA isn't out looking for small scale growers and trying to make sure everything is up to speed and everything's done perfectly. But if we're finding that through small scale seed production and selling that we're getting weed seeds or disease that's going out through these small seed companies, that could become an issue. And then we could become overregulated, and that can be a very difficult and expensive problem for small scale growers. So maintaining a high standard is very important. And yeah, I think it's important at a small scale to do your best to follow the methods as well as you can. And once you start getting into a rhythm, it becomes easier and easy to follow the standards to a higher level. So there might be things that you just can't do. I mean, you don't have the time or the space. So understanding the standards, so you're doing as much as you can, and then improving over time. So your testing is getting better and better and better each year you're testing. So yeah, so let's all cover on this here. Here's some lists to some of the references I used, including the Seeds Act and regulations, which are important just for being familiar with, as well as the methods and procedures for testing seed. And once again, there are different standards you can use. They're all fairly similar, but picking one and being consistent with that is important. So yeah, that's all I've got there.
Thank you so much, Chris. And the links that you're showing on your screen right now, Steph has dropped into the chat, and we'll also send out to folks afterwards. So thank you so much for sharing that. It was really helpful for me to understand how you interact as a seed company with the regulations. And I think we have Aaron able to join us now. Is that true, Aaron?
Can you hear me now?
We can hear you.
There we go. Third time's the charm, geez. Okay.
So Aaron's of Hawthorn Farm Organic Seeds, and he's going to tell us a little bit about the process that they're using there on their vegetable and wild crops as well. Seed company.
Can you see that? Is that good?
We can see that. Looks beautiful.
Yeah. So essentially what we're doing is we're building off of what Debbie was talking about earlier and what Chris was talking about as well. So we are using those CFIA guides and AUSA guides to, I'm giving it all away. Basically what we're doing here is we don't have a fancy germ chamber like the one you saw in the beginning of the presentation. Ours is a refrigerator that we picked up off the side of the road that was dead, and we control the heat with a timer and a light bulb. But the principle is all the same. this basically the way we've set it up is that we're trying to adhere the best we can to these standards, and sorry, I'm not having a good day today.
The tech fairies are out to get you. You're doing great.
I know, It's because Kimberly's in the building. She's a walking Bermuda Triangle. Okay, so these are the factors that help me build our schedule. So I kind of group the tests based off of what is needed, and I can set our germ chamber accordingly. What the test needs, light or dark, and then how we recreate that in our situation. And then, yeah, we use a very similar guidelines. We refer to the book often. We do paper towel tests, roll-up tests, sand tests. We do a lot of scarification. We do a lot of strat to try to break that dormancy. So all that kind of has to be factored into how we're building our schedule for testing. Testing isn't a one and done process. It's a around the year type of process, just because it creates so many bottlenecks and takes so much time. For some of the strat stuff, we're talking a month or more in the fridge before you can even start the test. So we have to kind of factor that in. And then, yes, it's a pared down system. We use a lot of paper towels and templates. On the top right, you can see how we preload the test boxes. We just do them in mass. And then under the EFAO sticker is a digital display where I can track the high and low and the humidity in our little germ chamber, and then I can control it based off of the size of the bulb, how long it stays on, and how much water and container I can put in the chamber. And then the bottom is just simply unheated. So if I'm doing a lot of cold tests, I can turn the bulb right off. If I'm doing a lot of, pepper and eggplant, then I can put a bigger bulb in. So I can really have a lot of control over what that environment's like. And then just like Chris was saying, like labeling is your key to success. Label everything. And then what we do is through the life of a batch, it is attached a lot number to its name. And then we can track that data over time. So the top here is a very, very brief sort of summary view of what's going on. And then that talks to the rest of the system in terms of if something's been released from quality control, like if it's past its germ test, then we can start changing packaging and updating that, and then we can start doing our printing runs for packing to then get on the rack to then fill orders. So it's a multi-step process, and one depends on another. So it's important to keep the flow going. And then, of course, it's not good enough to just see a seed sprout and then go on with your test. There's different time frames for that test to take place. And then, like Debbie has been outlining, what you're looking for in a germinated seed. And then the bottom left is one of those ring counters. It's one of the best things I ever bought for germ testing, to really keep an accurate count. Once you pull the little seedling out, there's no going back. So make sure that you're tracking, what you're counting. And so this is mainly what we've been working on as a schedule. And again, we're trying to hit those targets that have been set forward of each batch or each lot is getting a test every 6 months. So that means there are some months of the year where we are exceptionally busy. And then you can see June's rather empty, just because we try to buy ourselves enough time. If we can't be doing the testing properly, we try not to do it because it takes a lot of time for us and energy. Like, we don't use a vacuum seeder or anything like that. It's all done by hand. So the risk of losing tests or keeping track of the quality control is way too high. So we just give ourselves a month off because we're outside trying to farm and plant and do all that stuff, and then catch up later. And then the bottom, September, October, November, December, we're trying to keep up with stuff that we're getting ready to pack into the new year or the upcoming year. And then all these gray slots that say incoming, and that's seed that's either going to be coming in from contract growers if they don't have a germ test, or suppliers that do have a germ test, or we're going to have to redo them, or seed that we've grown in the field. So those lots tend to come in based off of, all kinds of factors, weather, so on, and seed cleaning and all the other things. But ultimately, the germ test is what determines which lots that we're going to pack. So sometimes when we're looking at germ rates, we don't look at where the seed comes from or how much we perhaps may have paid for it, or time and labor bringing that seed crop in. We're strictly looking at quality control, so sometimes it's heartbreaking dumping seed, but it's for the best, really. And then we also are doing germ testing to look at whether or not we can improve our purity. So what's not pictured in any of these slides is a really nice magnifying glass. It's very helpful. Making sure that the seed is clean, and then a quick germ test or a proper germ test can tell us if we are on track to getting some clean seed, or if we're running into issues, or if there were some mechanical issues, like we've split the seeds open somehow by breaking them during the cleaning process, or a batch, say, of tomato seed was under fermented and it's not sprouting, or something like that. We can start to see those things before they become a problem down the pipeline. So because we have so many things to pack, it is a process that has to happen year round. Otherwise, we'll end up in a huge bottleneck, and we won't be able to put seeds into envelopes, which is kind of what we do. So making sure that those are continuing through and constantly doing those tests it just makes the whole process seamless. And then, of course, you'll see in January, we're testing seed that we're going to be growing out. We refer to it as stock seed. We don't necessarily have an official stock seed program, but that's seed that we're going to be growing ourselves or be sending to growers. We try to make sure that seed is good quality. And then we have farm seed that we keep on hand. So they're batches that we're growing strictly for ourselves. grow out again and again and again. So that's its own stream. So there's kind of two streams. There's like the farm seed side, which the seed we send to growers and use for our own use, and then the processing side or the packaging side, where those are batches that then go, you know, into envelopes and then onto people who are growing seeds for their gardens. So that's mainly the overview. And then the how-to really does break down through those CFIA manuals and the AOSA manuals. And then we find that being able to capture data over time really gives us a sense in terms of what we can expect for seed longevity. That helps us also plan our grow outs, so we can look back and look at 3 or 4 years worth of data and see what we can expect for our lots, and we can see how well we're storing seed too, which is very important. In terms of the testing, we try to do 3 replications. It's important just to make sure that if we're having a problem with a test, we can see if it's the test itself, or we can trace it back to the lot, or what's going on. So it is a lot of work, but it's valuable work for us, and it's a good baseline for the quality of seed that we're putting into packets. And then how we are determining which batches we're going to be packing, and so on. So that does it for me. Apologies for the technical drama, but I'm looking forward to if anybody has any questions or anything like that. I'd be happy to help.
We do have one clarifying question, Aaron. Perhaps you can answer. At what temperature do you store your seeds?
Temperature in Fahrenheit plus humidity will be less than 100. So depending on the season, it can fluctuate, but then we try hard to keep it in that tolerance. In the future, I slowly am building a more robust storage room that's actually really closed off. But yeah, right now we're just consistency, I think, is the main thing for us.
Well, thank you so much for leading us through that process and how you're doing it at Hawthorn. I think maybe we'll invite Debbie and Axel and Chris back into the into the room. If you, Aaron, want to stop sharing, and maybe we can have if you have questions for each other, or the audience has questions for our presenters, I would welcome them. We do have one question here from Kathy asking, perhaps this is a question for Chris or Aaron, do you do any lab tests for disease of your crops as a small seed company? Debbie, you can also answer this if you want. Go ahead, Chris.
Well, I'll throw it out. So we do not send stuff to the lab currently, but we try to keep, this is something we've discussed because we want to keep up with if there are any known diseases within specific types of seeds. So as an example, a lot of the brassicas in the Pacific Northwest of the US are suffering from blackleg. So this is something that you'll see on a lot of the small scale seed companies' websites. They'll say, like, we do not sell any of these without testing them first. And I think we need to be mindful of that, because that is a disease that can transfer onto canola. And if we were to bring that disease and have it transfer onto canola, we would get in trouble very, very big trouble. So again, even though we're small scale, we want to be mindful of that. So that's something that's on our radar. And I think if we were seeing regular feedback from customers saying like lettuces or this or that, we're seeing disease issues, we would have to step that up. And we know there are labs in the Lower Mainland that can do that, and throughout Canada. We might end up sending them to the prairies. I think they've got some better labs there. But as it is now, we do not do regular disease testing in the lab.
Thanks, Chris. Aaron, do you guys do any disease testing?
We don't send any out for testing. We've been looking at those Igdia test strips specifically for onion lots. The problem that we run into is that we don't grow large enough batches to warrant the strip, because some of them are like $500. So that's where we kind of get a snafu. But yeah, same thing like in terms of worrying about FOMA or anything like that. If we're bringing in seed from the West Coast and stuff like that, we're getting them from sources where they are able to get that testing done quickly. That would be my main concern, is some of those, especially onion crops. And then, yeah, brassicas, like especially kale, would be the ones that I'd be mainly worried about. And then, I mean, the one question I have is, anybody does any heat treatments for killing off seed-borne disease on a small scale, or treating seed that you would suspect to be high. I think for us, it kind of starts in the garden, like save seed from healthy plants is number one for us. So if it's looking suspect, we'll bring it in.
Yeah.
That's a big part of it for us.
Yeah, we had a question on the registration form around having sent out germination tests to different places and getting two different germination numbers back, and was wondering if this is a common thing, but it sounds like both of you have not been sending out tests.
I'll comment on that quickly. I mean, you
Yeah.
see this with soil testing as well. You send soil to one lab, you send it to another, it comes back with different figures. So the important thing there is consistency, always using the same lab, double checking with their methods. So it might be that for particular types of seed, the AOSA and the CFIA standards are a little different. So I mean, even a 2 to 3 degree temperature difference could make a change in how the result will be. So that's important information. I generally find warmer temperatures do better for most seeds, except for the ones that need cooler temperatures for sure. And so yeah, if one's germinating at 22 and one's at 25, that difference between 22 and 25 Celsius is actually quite important. Around the 24, 25 degrees Celsius mark is where I notice like some germination rate changes really take place. So yeah, that could be a thing. So knowing the data, around what the tests are can help you understand why those tests are different.
Thanks, Chris.
That's why you replicate your tests. That's, do 3 or 4 or 5 and then see where it takes you.
I know Debbie mentioned the paper that she was using was specifically like germination paper. There's a question here. How important is germination paper? If so, where can you source it in Canada? People are wondering that. There's another comment that they bought anchor paper from the US, but the shipping was just really expensive. So curious around your experiences with germination paper.
Yeah, we buy our paper from the US too, so
yes,
can't help there, sorry.
But you find it, Debbie, important to get that germination paper and use it.
The good
or
thing
is
about
paper
germination
towel
paper,
okay?
Yeah, you know, a paper towel is fine. The nice thing about germination paper though is the roots can't grow through it. So if you use a paper towel, the roots can grow through it. So it's a little harder to see if if there's any sort of discoloration or damage to any of those roots, or if you're planting those seedlings after their germination test, is a little more difficult as well, right? So that's why we do use the paper, but there's paper towel. I know home use, everybody uses paper towel, right?
Yeah. Okay, that's really helpful. Helpful to know you're also getting it from the States. There's a question here, maybe either Debbie, Aaron, or Chris, who are doing germination tests. Does anyone use distilled water for germination tests? Head shake from Chris. Head shake from Aaron.
Yeah, we do use distilled water.
And you do use distilled water. Okay. Can I ask the purpose of that, Debbie?
Well, it's easy for us to use distilled water. We have, a tap in our lab. So, it's not, it's not expensive for us. We're not going out and buying it. So that's another thing. So it's just always been our standard, actually. Yeah.
Yeah.
I'd like to comment on that there. You really have to follow the same procedures if you want to replicate. And you, Chris, you mentioned it, right? And there are small things that germination is a very sensitive thing there. Only by following same procedures, you will get reliable results. You see fluctuations if you work with applications you are wondering, right? You try to exclude as many factors and then you follow a procedure you can compare. Otherwise, you are lost. And the paper can be what I hear. There's bleach is used for these kitchen tables that could interact with some seeds. So this is not for nothing that we do that, right? But of course, we have to follow a little bit the scientific standard. Where we are weak, and Debbie said that is the number of seeds and the replication, because we don't have the CFIA. They ask for 8 replications with many seeds. We can't use our small seed lots for that. And there we are weak. That's a weakness in but we get some idea. But it's really important to try to have consistent conditions if you want to compare that.
Yeah. Axel, there's also a question in the chat around what is your biggest challenge in maintaining the PGRC? I just think that the work that you do is so important. Our little seed companies and other seed savers are doing the in situ conservation in a way, but the work you do is also so important. So I'm curious about what are some of those challenges of maintaining the collection.
Main challenge is to grow the things out, right? When you grow them out, that is the dangerous or the difficult step. You talked about diseases. We have to look for diseases in the field there. If we see things, there may be seed-borne diseases we need to avoid. We try to avoid chemical treatments if we can, because one motivation is there could also be interaction with the genetic makeup of the material, right? But occasionally it may be required to avoid troubles or insect transmitted diseases and so on, or insects are the major troubles, other disease not so much. But we see in the cereals, you can see buns or things where they are seed-borne, and you have to act on that because otherwise you can cause trouble for your clients. And then we have, before we ship seeds, in particular abroad, we have CFIA inspecting the seeds, and the same is true when we bring in seeds. We have to pay attention there.
Right. Yeah, that makes sense. That makes sense. I'm just inviting more folks to ask questions if they need or have questions here. there was another question that came in during the like registration process, and maybe it goes along with the question from Kathy around how do you store the seeds, but wondering if there are any older simple technologies for storing seeds that you would recommend. The person is particularly interested in some of the ceramic containers that people have used in the past. How are you storing the seed at the PGRC, Axel?
Number one is dry. Number
Right.
one is dry. Temperature is good. If you can have lower temperatures, that helps, and we use that obviously. I can tell you, it took me a while to learn that the seed bank is located in Saskatoon, Saskatchewan. We have very dry air here. It's to our favor, absolutely to our favor, that we are in this environment here, that we have dry air here naturally. It's very important for you located there in Ontario or whatever, that you dry your seeds and you put them in sealed containers. If you have them exposed to ambient conditions, you have high air humidity, your viability will go down quickly. This is number one. Make sure you get the seeds dry. Number two, if you have them dry, sealed containers and then low temperatures, right? That helps. But number one is dry seeds, and before that, good seed quality if possible there, right? Seeds that matured well. We observed also in general, we get better seed quality when we grow in the field than we do in the greenhouse. For some reason, the maturing things mature outside. Maybe the changing of temperature, maybe higher temperatures than in a greenhouse where you have 20 degrees. That maybe helps the seed qualities in general.
It's really interesting. Another question, perhaps for Aaron, who you're growing a lot of seed yourself, you're taking off June to go out into the fields. There was a question about if you had any tips for how to harvest at the appropriate time to then optimize your germination rates.
Yeah, this is very crop specific. Especially like for some of the umbels where you're getting some of your best seed is sort of in those primary umbels. So if you are sort of late to the party, your best seed may have shattered, and you'll be picking up the latest seed to mature. And then in terms of seed quality, for dry seeded crops, if you're looking at lettuces or beets, like if you're looking at high temperatures and stuff, you can induce dormancy that can be unbreakable, and you don't want to end up in a situation where you have to like send out seed that's been primed, or you've mechanically run into some issues where, say, you've let tomato seed crop ferment for too long and then it started to sprout and you didn't notice, and then you let it dry. You can have some major quality issues that way. Heat can definitely be a factor. I've grown some really nice spinach crops over the years that have been beautiful, but I just have induced dormancy in one way or the other, and it just can never be, seems to be broken. So I would say it's really important to learn your crop and know what you can grow well in your environment, and then just sort of crop management, like keeping the weeds out of it as things dry down. And I can't say it enough, like labeling is your key to success all the way through, and through into the batch, like the life of the seed in a container. It's got a name and it's organized in some manner so you can track that process over time.
Mm-hmm.
Another factor can be threshing, right? If you thresh with a combine, you thresh too hard, you will not notice it, but you may damage your seeds, right? So really think every step through. Sometimes you don't see it right away, but you will notice, and things may germinate good to start with, but then they drop quickly, right? Because there is somehow a damage you don't see or you don't notice right away. Therefore, ideally, you want to go back. It's not decreasing linear, the viability, it drops, it can drop suddenly, right? So that's, and then you really have to think all steps through.
Okay. Yeah, there's lots of thank yous coming through, you know, merci, dankeschön, thank you. It's been a pleasure. Thank you, Erin. Thank you, Chris, Debbie, Axel. This is something that I've been wanting to make happen for a number of years, and I'm so glad that you are all willing to share your wisdom and expertise here with us today. There's just so much gratitude coming in through the chat for all of you, and so thank you all very much.